remember that for synthetic division, you can only divide by x minus c, otherwise you can't use synthetic division. You must fill in the missing powers of x with zeros, and you must divide on the left by the number c in the x minus c. So in this problem, we're asked to divide the polynomial 3x to the fifth minus 2x cubed plus x squared minus 7. Divide that by the polynomial x plus 2. Now, we have to divide by x minus c, so we're going to have to review what this x minus plus 2 looks like. But first, we'll draw the symbol, and then we list all the coefficients of 3x to the fifth minus 2x cubed plus x squared minus 7. It's plugging in zeros for every power of x that's missing. We have a 0 for x to the fourth. We have a 0 for x to the first. Do you see that? Now, what number do we put out in front? We put the c number out on the left side. But what is c? We have to divide by x minus a number. We're dividing by x plus a number, so we rewrite that as x minus a negative 2. That implies the c value is the negative 2. That's the number that goes out on the left. Now, we're going to leave a little space and make a line and bring down the first number. So we're going to bring down the 3 and then multiply. Negative 2 times 3 is negative 6. So list that underneath the 0. Add. 0 plus negative 6 is negative 6. Now multiply the negative 2 out in the front times the negative 6 and put it under the negative 2. That's positive. Negative 2 times negative 6 is positive 12. Now add, you get 10. Now distribute multiplication by negative 2. You'll get negative 20. Add, you get negative 19. Now distribute the multiplication of negative 2 times negative 19. You get positive 38. Add to 0, you get 38. Now multiply negative 2 times positive 38. Negative times a positive is a negative 76. Add, you get negative 83. That is our remainder. Okay, so now we have to analyze this. Our solution is going to be 1 degree lower than the original question. The original polynomial was 3x to the fifth, blah, 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 so it was a 5th degree polynomial. This one's going to be a 4th degree polynomial. So we're going to start by taking the first number on the bottom row, the 3, the negative 6, the 10, the negative 19, the 38, and the negative 83. Take the first number and multiply it by x, 3 times x to 1 degree lower than the question. So it's 3 times x to the fourth. Then just work your way down, powers of x. The next is negative 6. So we've got 3 times x to the fourth, right there. And then we have minus 6 times x to the third, plus 10 times x to the second, minus 19 times x, plus 38, plus a negative 83 over the divisor, x plus 2. Put a box around that. So you see where that came from? I took all the numbers on the bottom row of synthetic division, and then I listed those as coefficients of powers of x starting 1 degree with the original question. So it was starting with x to the fourth, and x to the third, x to the second, x to the first, then the number, then the remainder over the divisor.